Now let's solve some polynomial and rational inequalities. Notice we have a greater than symbol here instead of an equal sign. This is not an equation. If this were an equation, our critical values or solution would be 4 or -2. Because this is an inequality, we're going to have a set of answers, and we will not actually be including either of these numbers because there's no equality with this greater than symbol. So we're going to have regions of solutions. So I'm going to draw a number line and plot -2 and 4, and we need to see which of these three regions contains our solution set. Now I want to try and test a convenient number in each of these intervals. So in the center I'm going to choose 0, and on the far left I'll choose -3, and on the right 5 as my test values. So let's substitute them in. Let's begin with -3. In the first parentheses, -3 minus 4 is -7. I really don't need the -7, I just need the negative part. -3 plus 2 in the next parentheses would give me -1. -7 times -1 is +7, which is greater than 0. So 3 is a value that works in this inequality, and that whole region to the left of -2 is part of my solution set. Now let's try 0. 0 minus 4 is -4, and in the next parentheses 0 plus 2 is 2. -4 times 2 is -8, which is not greater than 0, therefore it is not part of the solution set. Likewise, 5 will give me a positive in the first parentheses and a positive in the second parentheses, and positive times positive will be positive, which is bigger than 0, and 5 will be in the solution region. So we can say that our solution set for this problem will be from -infinity up to -2, which we do not include, united with the region to the right of 4. Notice I'm not including the boundaries in either of these regions because there's no equation or equality in our inequality. This next problem is also given to us in factored form. Let's try and identify the critical values, which will be -5/2 and 6. 6 minus 6 is 0. And let's draw a number line and put them in their respective positions, -5/2 and 6. And I always like 0 as a test value because it's easy to substitute in. And I will choose 7 on the right. On the left, this is a -2.5, so I will choose -3 as a test value in the leftmost region. Let's try -3. -3 substituted into the first parentheses gives me -6 plus 5. That will be a -1 times the negative out front makes a positive. And -3 over here, 6 minus a -3, that becomes 6 plus 3. So I have positive times positive, which is not less than 0. So -3 will not be in the solution region. When I substitute 0 in, I get 5 in the first parentheses and 6 in the next parentheses, which is 30. Multiplied by the -8 makes a negative number, which is less than 0. So 0 is in my solution region. Likewise, 7, when substituted in, gives me a positive in the first parentheses, a negative in the second parentheses. So I've got negative times negative, which is positive, and it's supposed to be less than 0, so that is not a valid test point. So our solution set will only be between these two numbers, specifically the interval from -5/2 to 6, not including either endpoint. The critical values in this next problem already factored are 0, 3, and -2. So let's test those in the inequality. In numerical order, we have -2, 0, and 3. And so I need 4 test points. I will choose -3 on the left, -1 in the first middle section, +1, and then +4. Now let's see what happens. When I substitute -3 into w squared, actually when I substitute any of them into w squared, it's going to end up being a positive number for that portion of the problem, no matter what. Now let's try -3 here. 3 minus a -3, that becomes 3 plus 3, which is 6. Over here, -3 plus 2 is -1. 6 times -1 is -6, which is not greater than or equal to 0. So negative 3 does not work. Let's try negative 1. 3 minus a negative 1. That's 3 plus 1, which is 4. Negative 1 plus 2 is 1. So I have 4 times 1, which is positive, times a positive here is positive, and yes, that does work. Let's try 1. 3 minus 1, positive. 1 plus 2, positive. Positive times positive is positive, so it works there. Notice I'm not alternating back and forth between yeses and nos like I did in the problem above. I've got two adjoining sections which are solutions. Now let's try 4. 3 minus 4 is negative. 4 plus 2 is positive. I've got a negative times a positive plus this positive region there, which makes negative, and we want greater than or equal to 0. So that does not work. So our solution region is going to be everything from negative 2 on up to 3. And I'm including the endpoints because I've got equality included with this greater than or equal to. Well, let me make a comment here. Had this problem had a inequality that was strict, had this problem had greater than instead, then I still would have had these two regions, but I could not have included the endpoints, which meant 0 would have been left out of the solution set, and I would have had to have written this as negative 2 up to 0 united with 0 up to 3. So you've got to be very careful when you're dealing with these problems.